All right, so we've got a situation here where we've got a projectile being launched or kicked or thrown or whatever. But yesterday we talked that this was happening straight up, right? We talked about the physics of this problem. So I need to make sure you understand that when we graph this on our x and y axes, okay, the x-axis is actually a time, and the y-axis is actually a height, okay, or a distance. So when we see this written out in an xy graph, people think, oh, you're showing the horizontal displacement tied to the vertical displacement. How far we're actually showing the path of the ballistic. Okay, that's not happening. Okay, that's not what we're showing. You'll do that in physics. Here we're showing the height based off of a particular time. Okay, or the time being the, we talked about this. This is the independent variable and this is the dependent variable, right? So the height is dependent on what time it is, and that's the relation that we're graphing here. Okay. We talked that we have this general formula for finding the position of a projectile at a certain time. That formula is h of t is equal to negative 16t squared plus v sub naught t plus h sub naught. Okay? V sub naught is what we call the initial velocity, and h sub naught is called the initial height. Okay? Now, initial velocity is what our propellant, essentially. Okay? Initial height is where this thing is kicked from, launched from, dropped from, that kind of thing. Okay? When we're dealing with the 16, that's due to the acceleration due to gravity. Okay? Our differential equation that sets this up is negative 1/2 g, or gravity, times t squared. Okay? So take negative 1/2 times g, that's negative 32 feet per second times a half, which is negative 16. That's where that number shows up. Okay? So that's the physical application. There's calculus behind that. And when you are or do take a calculus class, you might talk about that and how we generate that. If we're dealing, so this is, like I said, this is feet per second. The other one is h of t is equal to negative 4.9 t squared plus v naught plus h naught, and that one is in meters per second. Negative 9.8 meters per second acceleration due to gravity in meters per second. You just got to pay attention to the units that they're talking about. Okay. A lot of times in WebAssign, they will tell you, hey, use the negative 16t squared plus v sub naught t plus h sub naught formula. Okay. On the final, they don't tell you that. They just give you the scenario, and you have that. Well, the last couple of years it's been in feet, but there has been a year that the final was written with meters. Okay. So just be on the lookout for that. Does that make sense? The math is still the same in each. Okay. I think WebAssign uses feet a lot because the 16 is a whole number, and then that sets themselves up for some nice factoring. Negative 4.9 is a nasty number to have to factor. Okay, so usually when it's meters per second, we jump straight to the quadratic formula and just run through that thing and get our solutions. You're going to hear me, so I called this V sub naught. Okay, sub referring to subscript, not referring to the zero. Okay, and that always, whenever something is sub naught, it's always referring to an initial. Okay, the beginning. Okay, time zero, essentially. You'll also hear people say V naught instead of sub naught. Does that make sense? So V naught, H naught, those are your starting velocities and starting height. So in this particular problem, it says a bullet is fired straight up at an initial speed of 800 feet per second. When we have that, do they talk about anything about where this thing's launched from? Does it say it's launched at the top of a building or from eye level or anything like that? No. So we have to make the assumption that this is done from the ground. So our V sub naught is the 800. That's our initial velocity. And actually, we're using this formula. And our initial height, because they don't provide any knowledge about what the initial height is, we make the assumption that it has to be 0. So that is the formula, that is the function that is going to tell you the height of this projectile at any time during its flight. Does that make sense? Okay. We want to know some critical things about it. I know I've got these questions A and B here, but I'm just going to go through the general procedures that you're going to do on all of these questions, because there's a collection of data, of information from each graph that is going to be consistent in every one of these problems. So the first thing you're going to want to do is you're going to want to take this thing and you're going to want to factor it, okay? Because my goal is for my h of t to be 0. And what happens? What do you think? Let's just think like physics application or the real life experiment going on here. If the h of t or the height is 0, what does that mean? Where does that put the bullet? On the ground, right? Okay. So it's either going to, because it's a quadratic, you're going to have two answers, right? Okay. So one of those answers is where it started on the ground. And the other answer is going to want to be when it gets back to the ground, right? Does that make sense? Okay. So in their phrasing, when it says, when does the bullet fall back to the ground, there's no numbers there for us to insert into our function, but it's an implied height at time t is being 0 or needs to be 0. Okay. So that's why we want to initially factor this thing with this being 0. I said one of the reasons they like to use feet per second is because they can then choose like a number like 800 as the initial velocity, and this thing's going to factor pretty conveniently. This thing will factor to a negative. So because I don't have a c term in my quadratic, you have an a and a b. You can always factor a GCF out, right? You can at least factor out a t, but in this case, I can factor out a negative 16t, and that's going to leave me with t minus 50. And there's my two factors, right? So negative 16t equals 0, and t minus 50 equals 0. Divide by negative 16 gives me t to be 0. Add 50 gives me t to be 50. Those answers, one of those answers should make logical sense. When is the bullet on the ground? Well, times 0 before I even pull the trigger, this thing's on the ground, right? Okay, so that answer should make sense. If you don't get that answer, then you got to go back through and look at stuff. Okay, if for any reason we were to have like shot this thing from a certain height, like 10 feet or 20 feet or whatever, something like that, then one of our times would actually be negative, and the other one would be positive. Okay, because if you start from an initial height, you have a c value. Your parabola is going to do something like this. And if this is my initial height, so this is where I fired it from, the parabola is going to intersect somewhere over here. Can time ever be negative? No, so that would be a useless point or value. Let's see if I can get rid of this stuff. All right, so we know t is 0, and we've also got this t is 50 as our other value. Okay, so that's nice. That's where we cross the x-axis. Those are x-intercepts. What is that highest point on a parabola called, or even the lowest point? Okay, it's the max or min, but it's a vertex, right? So the vertex is always located at what position in relation to the x-intercepts? Huh? Okay. What do you mean by middle? Middle is a pretty vague word. Okay. So I'm going to take my x-intercepts, and I'm going to average them. And that gives me the midpoint, right? Okay, so that's what I was looking for. When you say middle, I'm in the middle of heating in this wall, right? Well, what do you mean by exact middle? Middle just means interior between two things, right? So I need specifics. I need midpoint, right? In mathematics, we have to be specific. So midpoint. So we get T equals 25, right? That's where the vertex is going to occur. Now this thing is going to be concave down. So you said maximum earlier, right? So that point right there is going to be a maximum. And it occurs at a time, and then there's going to be a height attached to it as the y value. So the time was 25 seconds. Now how do I find, so this thing's going to be launched up. It's going to come back down, right? That's my parabola. How do I find this height of the maximum? Plug it in. Plug 25 in to my original function right there, right? So I'll come down here and do that math. So I'll take h of 25 is equal to negative 16 times 25 squared plus 800 times 25. All right, so we're going to do that. When we evaluate that, that tells us that the height at 25 seconds, if you evaluate this out, gives you 10,000. Okay, so at 25 seconds, our bullet reaches a height of 10,000 feet, right? Okay, and that's the highest it'll go. It won't go any higher than that. All right. Now, what is that? You guys talked about this last year. What is this line right here that passes through the vertex of any parabola? Axis of symmetry. Okay, which we can use to our advantage in questions like this. How many units is 25 away from 0? 25. How many is away from 50? 25. So that symmetry should exist. Now the symmetry should exist in a lot of other situations as well. Looking at part B, it asks us, when do we reach a height of 6,400 feet? Well, 6,400 feet might be like right there. So I want to figure out what was the time. So if that's 6,400 feet, what is the time then that happened? Does that make sense? Okay. It should also happen over here again, right? Does that make sense? Because on the way, so it reaches 64 feet on the way up, reaches its maximum of 10,000 feet, but then it's going to come back down. At some point, it's going to reach 6,400 feet again, right? Okay. So how do I find that? Well, it's the same exact procedure we've gone through. H of t is equal to negative 16t squared plus 800t. Initially, we wanted our height to be a 0, right? That's what we were interested in. Let's now let it be 6,400. So our goal is to try to figure out what the t value is when that height is 6,400. Okay, so whenever they ask you, when did it reach this particular height, then you plug that particular height in for h of t and then solve for t, and that will tell you the when. Okay, so again, this is a quadratic, so we factor it. So I'm going to go, I'm going to write it this way: 16t squared minus 800t plus 6,400 equals 0. I just moved. I like my t squared to be positive. I can factor a 16 out. 16 times 5 is 80, so times 50 would be 800, right? And 64 is divisible by 16 4 times, but it's 6,400, so it's 400 times. Is that okay with everybody? Just taking that GCF of 16 out. Can I divide both sides by 16? I'll cancel here, and then it'll leave me 0 over here, right? So then I'm left with t squared minus 50 plus 400. I guess 50t. I'm sorry, I forgot that t there. So what two factors multiply together give me 400, but have to give me negative 50? They both got to be negative, right? 10 and 40. So this is going to give me t to be 10, and this is going to be t to be 40. And those are the two times in which we reach 6,400 feet. Does that make sense? So I'm going to come back up to my picture, put t to be 10 there, t to be 40 there. How many units is 10 from 25? 15. How many is 25 from 40? 15, right? We still got that symmetry existing there. Okay, and that should always be something that exists when we do these. Yes. Yes. Yep. That's a good question. So this x-axis is seconds or a time. The y-axis is a height. So I want to make sure that we understand that graph is not showing the actual physical path of the object, right? Okay. The actual physical path of the object would be something like that. Okay. If there was an angle to the shot, right? This was going straight up though. Okay. In physics, you guys will talk about if we have like you might do like a baseball question where they say a batter hits a ball with an exit velocity of 110 miles per hour. Their bat had a launch angle of 30 degrees. Figure out the horizontal and vertical displacement of that ball, basically asking how high did the ball ever get, and then where did the ball land. Does that make sense? But that will be talking about, when you graph it, it will actually be the path of the baseball. Okay. So this kind of makes sense. What if they ask me, when does the ball reach 12,000 feet? It won't. Okay. Algebraically, what would that mean? Or what algebra could I do or would I see that would tell me I don't reach 12,000 feet? What kind of numbers would probably show up or maybe show up? Imaginary numbers. Okay. Remember when we do the quadratic formula and we don't intersect the x-axis, we can't factor it by product sum technique. We can't factor by AC. We have to use quadratic formula. And if it doesn't cross the x-axis, the quadratic formula generates our non-real solutions. Okay. So that being said, the last class had questions about number 13, I think it was. We started with it, but we didn't do it. All right, so the numbers here at this one are pretty similar to what we just did. We got 80 instead of 800. So it's going to factor nicely for us, but I want to talk about the structure of a lot of these questions in WebAssign. When they show up like A, B, C, D, E, a lot of times, guys, I don't necessarily go through them chronologically. I'm going to answer A, get an answer, and then go to B, do that work, get an answer. I'm going to do the problem holistically. Like I'm trying to, I know overall, like the last question we just did, we factored it, we graphed it, found x-intercepts, found maximum, that kind of stuff, right? Because if I do it that way, chances are I'm going to minimize the amount of work I have to do. If I try to go answer question A first, but I might have to do like question D actually on my way to getting to A, right? Does that make sense? And I think actually what we find out is that we actually do this backwards. I think we're going to find E, D, and C first, and then talk about the top two, okay? I just think that a lot of times when they structure their questions, if you abide by their order, you might be wasting a little bit of time sometimes. Just my personal opinion. So that's kind of how I'm going to approach this. All right. First things first, we're going to take our formula here, and we're going to plug in our initial velocity. So we'll have h of t is equal to negative 16t squared plus 80t, right? If I'm going to try to graph this thing, three things I need for every quadratic: x-intercepts, vertex. If I have those, I've got a pretty good graph in my quadratic. Okay? So let's find the x-intercepts. That's when h of t is 0, right? And if you think about it, h of t being 0, that's the key phrase, that's the ground, right? That's going to answer question D or question E for me right away. With this factor, take out a negative 16t, and I get t minus 5, right? So I get two answers. T is 0 and t is 5, correct? So t is 0, t is 5. There's my x-intercepts, right? Okay. Why did I only choose one of them? Yeah, when something hits something, doesn't have to be moving. So at the initial time, that ball is not moving. Okay. It's not until the experiment is conducted, the object starts to moving, then that we can say that it actually hits the ground. Okay. Where does the vertex occur here? 2.5, that's the time. And we know the vertex is going to produce the maximum. So the maximum, and we'll talk about this again in chapter 2, but the maximum is not the vertex. Does that make sense? The maximum is the y value of the vertex. Okay? Because it's the largest y value that we come, by definition, it's the largest y value on the graph. So the way I find that 2.5 is I took the average of 0 and 5, but now to find the height, I'm going to plug in that 2.5 into my original position function. Because that's what the position function does. It says it gives you the distance or the vertical height or the vertical position at specific times. Well, I got a specific time with 2.5, right? I plug that into my height function, and it gives me the height at 2.5, which in this case is 100. Okay? So it's negative 16 times 2.5 squared plus 80 times 2.5. And you evaluate that, it gives you 100. Okay, so that's my graph. So now we should be able to answer all but one of these questions directly. We can answer E. We can answer this. When is a word for time. Okay? What, in this case, is the height. Okay? It says, when does the ball reach 192? Well, 192 might be up here. Does the ball reach that horizontal line of 192? No. Make sure you spell things correctly when they ask you that type of stuff. Okay? And now ask, when does the ball reach a height of 96? Well, 96 would be there. Does it reach 96? Yeah. Okay, well, we can't guess. So I'm going to take the h of t is equal to negative 16t squared plus 80t. And now, initially we were interested in 0, right? Now I'm interested in 96. So solve that. If I solve this for t, I'm determining, and I'm going to set everything I'm going to move everything over, so it'll be positive 16t squared minus 80t plus 96. But what we're doing there is we're asking a question, okay, when, for what values of t, time and seconds, does the ball exist at a height of 96? Okay. So nice thing again about using the 16 and the feet per second stuff is that this factor is real nice. So t squared minus 5t plus 6. Divide both sides by 16. And now I get t minus 3, t minus 2. So t is 3 seconds, and t is 2 seconds. Is everybody okay with that? Okay. Why do I answer this with just 2 seconds? Okay. Keyword right there. Initially means the first one, right? So that's on the when it was on the way up, it hit 96. And then that was at 2 seconds. On the way down, at 3 seconds, it hits 96 again. That kind of make sense? Okay. I'm going to give you, now we already answered B as impossible, but some people maybe won't have the graph kind of completed in this nature to make the argument. Well, if I win 100, 192, they're not going to intersect. Okay. Some people are more analytical in everything they do, so they're more like a calculator and say, okay, I need to go through the steps algebraically and see what does the algebra tell me. So if I go h of t is equal to negative 16t squared plus 80t, and I put that as 192, going through the same process as before, we're going to factor now. 16t squared minus 80t plus 192 is equal to 0. 16 factors out again. I get t squared minus 5t plus 12 equals 0. And the idea then is, are there two numbers that multiply together to give me 12 but have to give me negative 5? And there are none. So what do? We turn to this. Opposite of b, plus or minus b squared minus 4 times a times c all over 2a. And now I get 5 plus or minus, okay, 25 minus 48, right? Negative 23. What does that negative 23 tell me? Imaginary, meaning I have no real solution. So now here's the question. That is actually the solution to that equation. It is, when does the parabola t squared minus 5t plus 12 cross the x-axis? Okay? That's not the same as the question, when does negative 16t squared plus 80t cross the line 192? Does that make sense, everybody? Let's kind of look at those two things together. And this is the stuff, this is the connections that you probably didn't deal with a whole lot in Algebra 2, but I think is important for us to recognize. So if I got 192 is equal to one of my equations, so put that, well, so in the left one we'll graph what we started with, y equals 192, okay, and then it was what, y equals negative 16t squared plus 80t. Oh, and I got to use x. Okay. So it's giving me this parabola. Okay. Let's see if we can mess with the axes a little bit to make this a little bit nicer. There we go. So we're getting that parabola and that line up there. They do not cross graphically, right? That's the scenario. That's the situation that we started with. That's the physical question that was presented. Does that make sense? Okay. Now, what we actually did is, working over here in the blue one, we said, when does t squared minus 5t plus 12, when does that equal y equals 0? And we're actually answering this question here, looking at the algebra of this. Does that make sense, everybody? But what we know, when we do equation, as long as we balance the equation, do one thing to both sides, and maintain that, is the solutions that exist for this problem are inside the solutions for this. Does that make sense? Okay. So because this one provided imaginary solutions, this one is imaginary solutions, meaning we do not cross at 192. Does that kind of make sense, the algebraic approach? Jackson, we okay? Okay. Questions on anything? Any, yes. Yes, I can. Okay. So number 16 looks like 1 over R plus 1 minus R, or R. 1 minus R is the denominator, is equal then to like 12 over R squared, right? Okay. This is a initially rational equation, right? Okay. Number one thing we don't like about it is fractions, right? What can I multiply by so that I get rid of fractions? Common denominator, and I want it to be the LCD, okay? Especially, so in normal things that we've done so far, some equations we've done so far, the denominators have never been variable, or it's been rare that they were variable, and it didn't matter whether we used LCD or just common denominator, okay? When they're variable like this, it's paramount that you use an LCD, because if I don't use an LCD and I just use a common denominator, it might create a cubic instead of a quadratic. And we don't know how to solve a cubic yet. Does that make sense? Or eventually, if the smallest that could be created is a cubic, if I use a common denominator, it might create a quartic or a quintic, and I don't know how to solve those yet. Does that make sense? So LCD is very, very important. So the way we choose an LCD is we just go through and pick the denominators that are non-repetitive, so the ones that are new, essentially. And if they do repeat, choose the ones that have the highest exponents. So if I look at this, R is a component to all my denominators, right? Okay, it's a new one, or one that doesn't has to belong to the LCD. But there's a power of 1 here, and there's a power of 2 there. So which one do I take? Power of 2. Okay? So R squared has to be part of my LCD. So the R squared takes care of that R, and it takes care of that R squared. Does that make sense? Keep going through 1 minus R. Is that a new denominator? So it has to belong as well. And that generates my LCD. So I'll multiply every one of these by that LCD. And when we do that, okay, here in this first, that R is going to cancel with one of these R's, right? So it's going to leave me with just 1 times R times 1 minus R. Is that okay with everybody? Okay. When I look at the second fraction, the 1 minus R's are going to cancel. And it leaves me R squared times 6. So 6R squared. And when I look at the last one, the R squareds are going to cancel. It leaves me 12 times 1 minus R, so that's 12 minus 12R when I distribute that. Distribute the R minus R squared plus 6R squared was 12 minus 12R. What's that? 5R squared plus 13Rs minus 12 equals 0. Just trying to move everything over at once. Make sure I did that right. So those give me the 5R squared. I added 12R over here with this current 1R. Gives me 13R, and then move my 12 over. That kind of make sense? I'm going to try the AC method, so negative 60. Are there any factors that multiply together to give me negative 60 and have to give me 13? Yeah, I can't think of any. So what do I have to? Yeah, I have to go down to the quadratic, and I'll leave that up to you to finish off. But using quadratic should get you those those two solutions. If at any time you guys can't think of any factors and you use the quadratic and the quadratic turns out to give you answers that are whole numbers or rational numbers, then it tells you that there were actual factors but you didn't pick up on what they were. Does that kind of make sense though? Let's see here. Do you see how, like, if I wouldn't have used, like, if I would have just created a common denominator, chances are the common denominator I would have chosen if I didn't know to use the LCD would have been R times 1 minus R times R squared. And what that would have done is it would have made every one of those in that last line be 1 greater power of R. So I'd have 5R cubed plus 13R squared minus 12R. And at that stage, because it's R cubed, I'm not sure what to do with that. Okay, you will eventually, but if we can keep things as simple as possible, that's what we're going to do. Anything else you guys want to talk about? Feel like we're learning things? All right. That 1-4 is not due until tonight, so make sure you finish that up. Tomorrow, I want to start the next section. So I got for you.